trigonometry and Berry. These two topics, they go hand in hand. We'll be looking at the IGCSE past paper. We'll take a selected questions from the different years from the IGCSE papers. Okay, so we're going to be looking at them, and we're going to make good use of our trigonometrical knowledge and our Berry knowledge of Berry. We remember, first thing I want to highlight. The first thing I want to highlight here is that we remember SOHCAHTOA. If you have a right angle triangle, you remember your SOHCAHTOA. SOHCAHTOA from trigonometry. We've done this before as students. Okay. Grade 9, you're supposed to do trigonometry. Grade 11 also, you're supposed to do trigonometry. So you have what you call the SOHCAHTOA. We're going to explain what SOHCAHTOA means. Okay, just as a revision, not as a new fresh class. No, as a revision. So SOHCAHTOA means sine is opposite over hypotenuse. This means sine is opposite over hypotenuse. Is that okay? Sine is opposite over hypotenuse. That's for so. The car is cosine is adjacent over hypotenuse. This C is for cosine. A is for adjacent and H is for hypotenuse. And TOA means tangent is opposite over adjacent. So these are the trigonometrical functions that you've studied before. Now, why we normally in Berry we don't use trigonometry? We don't use this particular trigonometrical ratios in Berry. The reason why we're using it for this question is that this question is a right angle triangle. Is a Antwerp, they've given us 3 towns: the Bruges, the Rotterdam, and Antwerp. There are 3 cities or 3 towns. Antwerp is 78 kilometers due south of Rotterdam. So if Rotterdam is here, 78 kilometers down due south means you have to go down. So you can see 78 kilometers here. And then this Antwerp, and we also say that, and it's also 83 kilometers due east of Bruges. So this Antwerp is also 83 kilometers due east of Bruges. So if Bruges is here, 83 kilometers is due east. 83 kilometers due east. Okay, so means Antwerp is here. So you can see here, this place is 90 degree. This place is 90 degree. Why? Why is it 90 degree? Why do we say it's 90 degree? Because you can see that this is southward and this is westward or eastward. Okay, so you can see from here to here is eastward, and from this Rotterdam down to Antwerp is southwest. So it makes a 90 degree. Is that okay? That becomes a 90 degree. Is that okay? Now let's take a look at what they want us to do. Now it says calculate the distance between Bruges and Rotterdam. The distance between Bruges and Rotterdam. That means they want us to find this one. They want us to find this distance between this place and this place. They want us to do. But we already know this distance is 83 kilometers, and we know this distance is 78 kilometers. So what we need to do, we know the horizontal distance and we know the vertical distance. We know the horizontal distance and we know the vertical distance. So all we need to do is to use what you call the Pythagoras theory. Why? Normally we don't use Pythagoras theory. Normally we are supposed to use either the sine rule or the cosine rule in trigonometry. Normally we use the sine rule or cosine rule, but for this question we're going to use the Pythagoras theory. Why we using Pythagoras theory to find the distance between Bruges and Rotterdam? The reason why we're using Pythagoras theory to find the distance between Bruges and Rotterdam is because it's a right angle triangle. This triangle is a right angle triangle. So here we're going to apply what we call the Pythagoras theory to find the distance between Bruges. Pythagoras. So theory. Pythagoras theory. Okay, we're going to apply this theory, which you learned in grade 9. You learned this in grade 9. Okay, if you didn't learn this in grade 9, then you have to visit any text that explains Pythagoras theory. However, in this video we go to itemize it. So if here is B, Bruges, I use capital letter B here, and here is R, capital letter R for Rotterdam, and here is Antwerp. I use capital letter A for Antwerp. Now we have A, B, and R. Okay, we have A, B, and R. So the distance between A, B, okay, so I can say BR square is equal to Pythagoras theory, apply Pythagoras theory, the hypotenuse, it's called the hypotenuse, the longest side square, which is BR. So the distance is BR. So I'll say BR square, that's the rule, that's the Pythagoras. Say the longest side square equal to the sum of the two shortest sides, the square of the two shortest sides. So it's equals to BA, is equals to the square of BA. So you say BA square plus BA square plus AR square plus AR square plus AR square. Okay, so this is what we call Pythagoras theory. So you can see this is easy for as a question. This is considered to be easy, right? So BAR square is equal to BA is 83, right? So we say 83 square plus AR is 78 plus 78 square. So you can see this question is very easy. It's very easy. It just requires you to apply the Pythagoras theory. Okay, this is equals to our BR square. Okay. We might choose to use small letters. The side facing B, this side facing B, we use small letter B. The side facing R, we use small letter R. The side facing A, we use small letter A. So that would be easier. Instead of writing this BA, we use small letters. Okay. Anyway, this one square, what do we get? 83 square, what do you get? We get 88688.9, right? We get 6,889. We get 6889, right? Square 78, what do we get? If we square 78, what do we get? We get 6084, right? So add them together. 6084 plus 6889. So we get 12,970. This will give us what? 12,000. That's not the answer. 12,970. 973. Okay. So because this is BR square, we're looking for BR, not the square. So we find the square root of both sides. So if you take square root of this BR square, you get only BR left. And you find the square root of this one, we see what we get. So BR okay, so what's the square root of this number? Square root, we get 113.8 or 0.9. So here we get 113.9 kilometer. We get 113.9 kilometer. Okay, so that's what we get. So here is 113.9. If we want to approximate to the nearest whole number, it becomes 114. 113.9 kilometer. So that's what we get for this distance BR. That's what we get for this distance BR. Is that okay? So that's what we got for this distance BR. So now let's go to the next question. The next question says this calculate is for A and B. Look at it. You can see it's separate. It says calculate before he gave us the A. This calculate also applies to question B. It also applies to question B. So he said calculate the distance between Bruges and Rotterdam. So we've done that. That's the distance. 113.9 kilometers. That's the distance. Okay, this question is from IGCSE paper. Okay, you can see it's easy. Just apply Pythagoras theory, you get this question. Now the second one is the berry of Rotterdam from Bruges. He said calculate. Okay, you know we are using this calculate. It's talking to A and B. Calculate the berry of Rotterdam from Bruges. Correct to the nearest degree. Here you have to approximate to the nearest degree. So in berry you must write, let's say R is for Rotterdam. So I must write it like this. Right? Rotterdam from, I write from. In berry I always tell the students to always write these numbers down. Arrow from what? From Rotterdam from Bruges. So I write arrow from B, if B is Bruges. Now when you write it down like this, what do you do in berry? This is what you do. You come, you say, you go to the one on the rightmost. Like you're reading some text like Arabic. You know Arabic, you read from your right to the left. Some other texts also, some languages, you read from the right to the left. So in berry we do the same. You go to Bruges and you start from the north. You go to Bruges, you start from the north and you count it to the line, angular distance. You know berry means angular distance. You know this word berry means angular distance, angle, movement in angular form. Berry means angular distance, movement in angular form, not movement in normal vertical or horizontal form. When you are moving a circle, that's berry. Okay, when your distance is taken with cognizance to your circular motion, then we call it berry in mathematics or in physics. Okay, so when they say Rotterdam from berry, you must write it down like this. You go to the one on the right and do it to the one on the left. So what we're going to do, I'm going to go to the one on the right and do it to the one on the left. Is that okay? We're going to go to the one on the right. Which one is the one on the right? Bruges. So I'm going to go to Bruges and count it to the line going to, meaning I'm going to start from the north. Always, you draw it for cardinal points. Okay? And you will do it to the one going to arrow. Meaning I just need to know this angle. That's the berry. I just need to know this angle. So since I just need to know this angle, how do we know this angle? This angle is not even inside the triangle. So what logic can we use? What logic can we employ to be able to get this berry, to be able to get this angle? Please pay attention, because Cambridge, you are not stupid. Don't think they will give you questions that will not require you to think. They expect that you have done a lot of hard work. So if you're not doing a lot of hard work, it's not going to be funny, to be honest. Okay? It's not going to be funny. You can see it's 3 marks. And it's very easy. So like I said, always write arrow from this. You go to the last one, the rightmost one, and start from there, from the north. Because even if there is no north, if Bruges was here, you draw it for cardinal so that you can see the north. And start from the north. But since we are talking about Bruges, you're starting from Bruges, on the one on the right. Don't start from Rotterdam. You go to the Bruges and do it to the line going to Rotterdam. Where is the line going to? This one. So we're going to do this one. Okay, so what we do here is just to be able to calculate this angle. Now, how do we calculate this angle when we see that this angle is even not inside the triangle? But one thing we should remember in mathematics is that this angle, if I want to call it theta, is alternate to this place. Is alternate to this place. Why? Because you see this is a straight line, this is a straight line, so they are parallel lines. These two straight lines are obviously parallel lines. So this angle outside, when you study angle of elevation and depression, you see that most of the time we will do that. This angle here is alternate to this angle. So if I call this angle theta, you can call it anything you like. You can call it angle x, You can call it angle whatever. But here I'm calling it angle theta. So meaning if here is 20, here must be 20. That's the meaning. If here is 100, here must be 100, but it's not up to 100 because it's an acute angle less than 90. So they are equal. Since they are equal now, we can now use this triangle to find this value. Whatever we get as this value will be this value. So what method can we use to find this angle? We can use this SOHCAHTOA I wrote earlier on. You see this SOHCAHTOA? If you can use either the sine rule or the cosine rule or the TOA rule, the target rule. So here you can see this is opposite. If you want to use tan theta, opposite, this becomes opposite. Why is it opposite now? Because it's facing this angle we looked before. Here becomes opposite over adjacent if I want to use TOA. But if I want to use sine, I will say sine is opposite over hypotenuse. If I want to use sine, I say here over this value. So let's use TOA, the original values they gave us here and here. So we can say opposite over adjacent is what? Opposite over adjacent is TOA. So I'll say tan theta, this is tan, this t is tan. So I'll say tan theta, tan, remember theta is the angle, what I call the angle. I'll say tan theta is equal to, if you like you write the formula, if you like you just go ahead. Equal to opposite OPP over adjacent. OPP over adjacent. Over adjacent. Over adjacent, which is equals to, the opposite is 83 over 78 over 78. The adjacent is 78. Okay, so that's the first step. 83 divided by 78. That's the first step. Okay, so this gives us tan theta equal to 1.064. Tan theta, this gives us tan theta equals 1.064. We can use four figures. 1.0641. Okay. So to get the value, no, this is not an angle, this is just a digit. To get the angle theta, you take the tan inverse. Meaning divide here by tan, divide here by tan. You know, if you divide here by tan, you become 1 over tan, which makes it tan inverse. So, or make theta the subject. If you make theta the subject, means you divide both sides by tan. This becomes tan inverse. On the right side, become 1 over tan is what? Tan inverse. You always write tan inverse. Take the inverse of tan of both sides. Tan inverse of 1.0641. Okay, we take the tan inverse of this value. So if we take the tan inverse, to get tan inverse in your calculator, you have to press shift and then tan. Press shift tan, you get the degree. So we get 46.8. So theta becomes, theta equals 46.8 .77 means 0.8 to 1 decimal place. But remember they say we should put it in the nearest degree. So it becomes what? 47. This becomes 47. Because they say we should put our answer to the nearest degree. So it becomes 47. Okay, this becomes 47 degree. You must put the small degree, okay? 47 degree. Degree is the unit. So you get your 3 marks for this question, and you get your 2 marks for this question. So you get 5 marks. So these are from IGCSE. So if you can do this, you will begin to feel proud about yourself. You begin to feel happy that you're making effort. Okay? So you must solve questions, and this will help you be able to figure out the other bigger challenges. Okay? So this is for this question. Let's take another question before we end this video. 2 questions for this video, okay? Another very question that we have to take a look at, okay? So the first one is 2 marks for this one, and the second one is 4 marks. So meaning you must be able to do the berry. The berry question is 4 marks for this one, okay? And the distance is a calculate the berry of relative. Okay, these are both of them are berry. So let's see how it goes. It says a plane flies from Auckland. I think this is New Zealand, right? Auckland, I think is New Zealand. A plane flies from Auckland to Gisborne on a berry of 115. So it flies from Auckland to Gisborne. Look at Auckland here. Gisborne is here. Remember I told you berry, you always start from the north. It's an angular distance, angular measurement. When you move, although the plane flew like this, see? The plane flew like this. But when they say berry, they talk about the angular motion, not the vertical distance like this, not this vertical distance. So when they ask you for berry, they're talking about the angular movement, this angular movement the plane has turned, the turning, this angular motion. That's what we call the berry. So every time we're doing berry, we do small 4 cardinal points, so we can start from the north. This way is the north. We can always start from the north, okay? We can always start from the north. Now, it's a plane flying from Auckland to Gisborne, a berry of 115. This is the berry, okay, of 115. Right? These 2 lines are parallel. They are parallel to each other. Right? So you can, if I want to extend it, you can see, maybe with broken lines. They are parallel lines, these 2 lines. They are parallel lines. This is 115, okay? And if you extend this line, you also get 115 on the other side this way. If you extend this line, you also get 115. So here we also be 115, this place, because they are corresponding angles. No corresponding angle for parallel lines. If here is 115, here will also be 115. Is that okay? Okay. So now let's see what we have left, what the question wants to say. So the berry from Auckland to Gisborne is on a berry of 115. Now the plane then flies on to Wellington. Enough then fly. It didn't stop here, he continued to fly. He flew to Wellington, to this place. The plane flew to Wellington. Angle AGW63, AGW63, this place is 63. The angle the plane make with him is 63, right? Now calculate the berry of Wellington from Gisborne. So when they say Wellington from Gisborne, so you say W from G. W from, always do this. See this thing? If you don't do it most of the time, you will miss the question. Always do this. So you come to the rightmost one. Now you know you want to do it to the leftmost. So you come to G and you do it to the line going to W. You start from G. After writing this, you come to the right. You start from G. So G, you do to the line going to W. Meaning you need to find, you start from G. G is here. You always start from the north, okay? Meaning I have to find this berry, this whole thing. I have to find it. But remember, I already know up to this place is 115. Here to here is 115. Right? Up to this place is 115 if you. So we just need to know here. We just need to find how we can get it here. And another way, okay, another easier way, maybe if you extend this line down, the whole of here to here is 180 already. So we just need here to know this place. We need to find this place and then we add it to 180. This is what we need to know. This place. Okay. So maybe if we know here, because we already know here, you know this whole side is also 180. This whole side, starting from the north in anti-clockwise way, is 180. What if we know here, we add this, we subtract from 180, we get the remaining value here, right? Another way of thinking. So let's see, how do we calculate this one, this place? Let's use a different color. How do we calculate this place? Could be one way. Because I know if we know here, we already have here, we subtract from 180, we get the remaining one for this place. We already know angle on a straight line, the whole of this one to this place is 180. Because the journey is just from here to here, right? The journey is from here to here. So all we need to know, we already know here is 180. 180. All we need to know is this one. Okay? So let's see if we have any way we can easily find this one. If we cannot find this one easily, then let's turn to this place, find here. If we find here, probably we'll be able to find. If we have a 90 degree here, we draw a 4 cardinal. So if we draw a 4 cardinal here, we already have 115 here. 115 minus 90, we'll get this small angle. You know, here to here is 90, here to here is 90. If you stop here, it's 90. So 115 minus 90, that's 25, right? So we get here to be 25, if we're not mistaken. Here is 25. Right? Here's 25. And does it have anything to do with here is 115, here we know this angle, we don't know this angle. Okay, I think we need to do what you call the sine rule. We have this distance, we have this angle. Okay, see, we have this distance, we have the angle facing it, we have the distance, we can find this angle. So let's find this angle first and see how that can help us. We already know here is 25. Let's find this angle. Okay, let's find this angle first. So we're going to use what we call the sine rule. We're going to use what we call the sine rule. Sine rule is sine 63 over this. Remember sine rule, we did it in trigonometry. Sine G over the side that is facing it, which side? 410. So I can, instead of saying sine G, I just say sine 63. Sine 63, because the angle is 63, right? Sine 63 over 410. Okay, for writing this color is not so good. Over 410 is equal to sine, sine theta. I can call here theta. Sine theta over 400. Sine theta over 400. Over 400. So we cross multiply, you get 400 sine 63. 400 sine 63. We are doing sine rule to find one of the angle, because we know one angle and we know two sides that are facing the angle. So you can use sine rule. So if you cross multiply, you get 400 sine 63 is equal to, you cross multiply this and this, sine theta, 400 sine theta, you say 410 times sine theta. times sine theta. Okay, so you make this one the subject, so you can say sine theta. I want to make it the subject. Sine theta is equal to whatever is on the left, the whole of this one, divided by 410. So it's equal to 400 times sine 63, 400 times sine 63, times sine 63 over 410 over 410 over 410. Okay, first we press sine 63. Sine 63, we get 0.89 something multiplied by 400. We get 300. So on top we get 356.4. 356.4 over the denominator, which is 410 over 410. So we divide 356.4, we say divide by 356.4 divided by 410. So we get 0.8. Our sine theta, so we say our sine theta will be equal to 0.869 to 8692 0.869268. So to find theta, the angle, you say sine inverse. Remember that. You now do the sine inverse. Press shift or press second form shift, this value, and then you get the angle 0.869268. So when you press that, you get 60.4. Okay, so theta is 60.4. Or you can just say 60. So our theta is 60 degrees. Okay, so this angle is 60. So if this angle is 60, how does it correlate? We know this angle, right? We can find this angle. 60 plus 63 is 123. 180 minus 123, take 57, right? So this angle is 57. Okay, so how do we then find this angle? Because we cannot say here is alternate to this, because this is not a parallel line to this one. Have we found this angle? And we cannot say this one. Okay, now we know 115, right? Here to here is 115. Let's find this small one. There's a small angle remaining here. If I bring this one down, there's a small angle remaining here. The whole of this is 115 plus 60. 115 plus 60. 115 plus 60. That's 175, right? So so here is just 5 degrees. here is 5 degrees, right? So if we do this one 115, here is 60, here is 25, here is 115, here is 60, here is 5 degrees. Now let's take a look at this side. Here is 60, 63. Here, what's this angle? What's the alternate to? 60, right? What is the whole of this? That's 65, right? The whole of this is alternate to the whole of this one. Are you with me? The whole of, see, from here to here, this 5 and this 60 is alternate to this one. So here is 65. If here is 65, 63 plus 65 is 128, right? 180 minus 128, we'll get the remaining one here. 52, yes. So this place is 52. We've gotten it. This place is 52. Sorry, okay? I know you'll be saying, oh, it took so long. Okay, I'm trying to break it down in a way that it's easy for us. So do we understand how we got 52 here? Here is 52 because, see, I got here 65. Do you understand how we got 65? Because I got 60 here. We cannot just say this 60 is equal to this one. You know why? Because it has to be from this parallel line and this parallel line. So I have to do the whole of this. And to do the whole of this, I already know this is 115, this is 60. I must find what is remaining here. I add this and this is 175. Take it away from 180 and get 5. So 5 plus 60, I'll get here to be 65. So this 65 is alternate to this one. Because a line joining two parallel lines. You know this is a parallel line. This line and this line, they are parallel. They are parallel. So this 65 is equal to this. So if here is 65, you now add, you know, from here to here is 180 to this side. All the way from here, and go on a straight line is 180. If here is 65, 65 plus 63, 65 plus 63, you take it away from 180. You add them together, you get 128. Right? You get 128. So to find the remaining angle, because I just added this and this together, to find the remaining angle, which is this one, I'll say 180 minus this 128, I'll get 52. That's how I got 52 here. So once you get this 52, your problem is solved. Now, the bearing of the one they want us to find, the bearing of Wellington, I wrote it somewhere. Okay, Wellington from Gisborne is to say 180, that means the whole of this straight line, look at it, the whole of this straight line plus the 52. So you say the bearing is 180, the bearing of Wellington from Gisborne, Wellington from Gisborne. The second part might be easier because we've almost found all the angles. So if you're doing this other one, might be easier. Okay, from Gisborne equals to 180 degree. 180 degree. Where is the one you remember you start from here? Let me use a different color. Remember you start from here. Here to here is the 180. Then before you now add this 52, the one we just found now, this 52. Okay, you say 180 plus 52 plus 52 degree. That will give us 132. Sorry, 232. This will give us 232 degree. Okay, so you get your 2 marks. So what are the things we did? This question is supposed to be like 3 or 4 marks. Because before you could do this, you must be able to know this one. And to know this one, you use sine rules to find this angle inside. because we don't know here. Since you don't know this small one, you will not be able to tell this one without using sine rule. After you use sine rule, you add this 60 to this, 60 plus 115, you get 175, minus 180 minus 175, you get 5 here. That 5 plus 60 is alternate to this side. It's alternate to this one, which is 65. So once you get 65, 65 plus 63 is 128. Take it away from 180, you get the 52. It's because of this 52 that we'll be moving around the bush. So you get this 52. Once you get the 52, or another alternative way, when we got this 60, this cannot be, we cannot just say 57 is equal to this one. This one is bigger than this. You subtract this 5 away from it to get 52, then you say that 52 is equal. But that one will be like tricky for you. That's why I did go this way. So that's how we got this bearing. Now let's see the second bearing. The distance from Wellington to Gisborne is 400. We already know that. And the distance from Auckland to Wellington is 410. We already also knew this. Right? Calculate the bearing of Wellington from Auckland. So bearing of Wellington from, so you must write Wellington W. You don't have to write the whole word. Just write W from what? From A. You must write this. Remember I said to get bearing correct, you must write this thing down. Then you come, after writing it down, you put a dot on the one on the right, you do it to the one on the left. Like you travel to the one on the left. Okay? So you go to Auckland. There's Auckland, and you do to the line going to Wellington. There's Auckland. Auckland is this one. Auckland is there. There's A. Here, right? Here. Auckland. So you start from the north. If you start from the north, you are going to the line going here, going here. See, I told you the second one you don't have to do anything, and it's 4 marks. Because all the things we were doing just now that looks hard is because we are solving everything together. Okay? So here to here, see your job is done. You already know here to here is 115. See, to this place is 115, right? 115 plus 60, that's the bearing you're looking for now. Because you're stopping here to the line going to Wellington. Are you with me? So this is it. You move it from here. You already know, you're only looking for this bearing here to here. From A, starting from north, yes A, start from the north. You measure the angle. I'm not saying measurement by like taking a protractor. You read the values. Here to here is what we are looking for. But we already know here to here is 115. And we already know inside here we calculated 60 already. So our bearing will be 115 plus 60 plus 60. That will give us 175, right? 175 kg. Bearing must be 3 digits. If you have bearing from 0 to 99, if your answer is from 0 to 99, how you write the answer in bearing? For example, if your answer is 46, if you want to write it in bearing, you don't just write 46. You write 046. In bearing, you must write answers in 3 digits. When you took this topic, we already explained that. It must be in 3 digits. But these ones are already 3 digits. You don't need to put the 0 from the beginning. So your answer is, you see these 4 marks? These 4 marks is because, it looks easier now because you've already done all the hard work here, trying to find each of the angle. We already found each of the angle. So that's why this one looks easier. Okay, so that's all we have for this. We have many of these questions for bearing. We're going to be looking at them one after the other. Okay, because trust me, in the exam paper 4, you're going to have questions like this. You're going to have questions like this. Bearing and trigonometry combined. You'll be using the knowledge of the trigonometrical function and bearing. So that's the end of this class.